Hi, my name's Ben. I'm a senior hardware engineer at Emesent, and today I'll be showing you through our Vehicle RTK solution. Our Vehicle RTK is a mount designed for all types of vehicles. It's ideal for road surveys, coastal surveys, or anywhere where you can't fly or walk the scanner easily. Today I'll be showing you through what's included in the kit, how to set it up, how to configure the Emlid, and also how to process your scan in Aura. This is what's included in the Vehicle RTK kit. You'll get a quick start guide, a vehicle mount with a spacer, and underneath is a bag with the cables. Below the phone box is a vacuum mount option and a safety tether. Now I'll show you how to set up the Vehicle RTK mount with Hovermap. For this, you'll need the vehicle mount with the extension pole. You'll need a battery, a Hovermap, an RTK receiver, and the cables in the bag. Remove the spacer pole from the mount and set up the feet. These will be adjusted on the vehicle later. Turn it over. And install the GNSS pole. And then the Emlid receiver. Take the Emlid cable and plug it into the extension port on the receiver. The other end goes on this side of the vehicle mount. Hovermap is mounted on the front, and its cable goes on the other side of the mount. The battery slots in underneath. There you go. Now we can turn on our Emlid. Hold the button for 5 seconds. And we can configure this through the Emlid Flow app. Now I'll show you how to configure the Emlid settings in the Emlid Flow app. Open your Emlid app. Select your receiver and go to Settings. Position streaming 1, and make sure that this is set to RS232, baud rate 115/200, format NMEA, and now go into the NMEA settings. Make sure that GGA, GSA, GST, and ZDA are set to 5 Hz, and GSV is set to 1 Hz. Also, if you're using an RS3, make sure that your IMU tilt sensor is set to off. In order to configure your corrections, you will want to go into correction input. And at the moment, I've just got this set to a local government network. As you can see, we have an RTK fix with about 1 centimeter easting and northing precision. We can then swap into switch on to Hovermap and go into Commander. This is where we'll set up our settings to start a scan in Commander. You'll notice that it's connected to my Hovermap ST5009. And I'll start a scan by going New Mission. Non-autonomous mapping mission. Check all of these. And continue. Here is where you'll see, if configured properly, the RTK will come through, the status will come through in Commander. You can see that precision there, and that we're using 20 satellites. You You can continue on to the next page, label your scan, and start. Once starting a scan, you can then continue and you can view your RTK status in Commander. So I'll go continue and we can view our scan here. I've got RTK float, so I'm going to walk a little bit, and when I'm out in the open that should pick back up. Here you can check your RTK status. Now we've set up our vehicle RTK, well, I'll show you how to mount it on the vehicle. For this application, we're doing a road survey, so we want to see the road, the markings on the road and the curb. We'll mount it to the back of the vehicle so the Hovermap can see straight down onto the road. Make sure the magnets are mounted securely and tighten up all of the leg handles. Check that everything's secure and turn on your Emlid and your Hovermap. Now you can install the optional safety tether. Make sure it's all secure and we're good to go. Now that we've finished capturing our data, we can offload and process in Aura. To offload data, use your USB and plug it into the back of the Hovermap. You'll see the lights swipe side to side, and you can also monitor the progress in the web UI. Now that that's done, we should transfer our scans to the computer. Aura is more reliable when you're processing scans from your computer and not directly off a USB drive or external SSD. In Aura, you can go Process Scans, Add Dataset, select the folder. Aura will check what sort of data is in that scan, and it will come up and say backpack RTK is detected. We want to use that RTK data. It also says to check your CRS, coordinate reference system, and receiver type. So we'll go to process settings. Double check that the scan is picked up as backpack. Check your receiver type. In this case it was using an Emlid, but we also did scans using a Trimble R12. And update your CRS. In Australia, our corrections from our RTK base station are in GDA 2020. So we can either search for that, or it will come up in recently used here as well. During processing this data, I would like to reproject it as well. So I turn on reprojection and use the local CRS that we want for this project. In this case, it's NGA Zone 56. We'll also like to apply a geoid, which is the AHD, Australian Height Datum, in this case. Depending on your location, you might have different CRS and geoids. Click Save, and we can process this data. Here's one that I did earlier. I can view files here. I can open the subsample data or the full size, depending on if you want to do more with it or just check. And you can check what we have accuracy report either on the right hand toolbar here or in the output files down below. So fit metrics, view. This will tell us how well our RTK was reporting. So in this case, we have 99% of a fix because we were mostly outside. The accuracy reported by the RTK receiver was about 14 millimeters, 90% of it was at least 14 millimeters in the horizontal and 17 millimeters in vertical. That's just what the receiver reported. And the last table will show you how well the trajectory of the RTK unit aligned with the trajectory of SLAM. That's after we've processed and fit SLAM to the RTK, but this will show any outliers in either poorly reported GPS or areas where you go inside or under tunnels where you have lower quality GPS. This might show up as some larger numbers. In this case, we're still 25 millimeters horizontal in 90% of the cases and 28 millimeters vertical. So that's a pretty good alignment for a typical outdoor scan using an Emlid receiver. Yeah, now you can go and use your point cloud data however you would like. This has been reprojected to the coordinate system that we want, and you can see all that information up here.